Hey guys, we're going to go to Chapter 10.2, which is hypothesis testing for population means when your standard deviation is known. So let me go ahead and open this up. I'm going to bring up the PowerPoint. Okay. So let's go ahead and do this. Okay. So you're going to learn to use rejection regions to draw a conclusion and the p-value to draw a conclusion. Okay. So when a population standard deviation is known, which is sigma, the sample taken is a simple sample, and either the sample size is at least 30 or the population distribution is approximately normal. The test statistic for the hypothesis test for a population mean given is Z equals the sample mean minus the population mean divided by the population standard deviation over the square root of the sample size. Okay, so let's break this down into English. Okay, when you know your population standard deviation, you know your sample was a simple random sample, either your sample size is at least 30 or your population distributed is normal, and you could do that by testing it. This is what you use, the Z formula. Okay, so X bar is your sample mean, the mu is your population mean, which is your presumed value for the null hypothesis. Sigma is the population standard deviation, and N is the sample size. Okay, your alternative hypotheses will always and forever be less than value, greater than value, or not equal to value, okay? Because remember, we found out in 10.1, null is where it equals, okay? So you always have to have one of these for your alternative, always and forever. There's only 3 choices. So if your alternative is a less than value, it's a left-tailed test. If it's a greater than value, it's a right-tailed test. If it's a not equals value, it's a two-tailed test, because you don't care if it's greater than or less than. You just care that there's a difference. Okay, so you're going to reject the null hypothesis, which is HO, if the test statistics calculated from the sample data falls within the rejection region. Okay, so let me say that again. You're determining the rejection region, and if your test statistic falls in that region, you reject your null. Okay, so here's another way to think about it. Reject your null hypothesis if, for a left-tailed test, Z is less than or equal to negative Z alpha. For a right-tailed test, Z is greater than or equal to Z alpha. Or for a two-tailed test, the absolute value of Z is greater than or equal to Z alpha over 2. These don't make sense right now, but they will in a few minutes. So let's quickly talk about a p-value. A p-value is the probability of attaining a sample statistic as extreme or more extreme than the one observed in the data when the null hypothesis is assumed to be true. That's what a p-value is. It's a probability that this is going to happen again. Okay, I'm going to stop here and we'll go, the other videos will show them step by step.